So we're on the next group of 3 problems, 45 through 47. So this is job interviews. 3 men and 3 women are waiting to be interviewed for jobs. If they're all selected in random order, find the probability of each event in exercises 45 through 47. So what's the probability that all women will be interviewed first? So it's a 3-step process. First interview, second interview. Of course, this is without replacement, so you're going to have a change in the probability for each step. But it is an and probability. So what we'll do is we will take the probability of basically event A, multiply by the probability of event B given event A has happened, and then multiply that by the probability of event C given that A and B have happened. So it's a little bit longer. It's one more step. So let's think about it. We have 3 men and 3 women. So the probability of picking a woman for the first interview, because it's random, there are 3 women, there are 6 slots. So that's the probability of event A occurring. So let's just write that we have 3 women, 3 men, for a total of 6 people. Okay, so now if A is true, then what's the probability of B happening? Well, B is another woman. So at this point we have, if this is true, then we have 2 women, 3 men, and 5 people. So the probability of picking a woman in this case is 2 divided by 5. 2 women out of 5 people. And you can see what happens now. If this is true, if A and B are true, what that'll leave us with is 1 woman and 3 men for a total of 4 people. So the numerator, again, is the number of women, and the denominator is the total number of people to choose from. 1 woman out of 4. So to find the combined probability, you multiply these things together, and you get 6 over 30, 6 times 5 is 30, times 4 is 120. And you can divide both numerator and denominator by 6, and you'll get 1/20th. 1 over 20, 1 divided by 20. So that's the probability of picking 3 women. So originally we have 6 people to pick from randomly. Then the next time we have 5 people, then 4 people, and then the other appropriate things. So that's how that one works. The first 3 interviewees will all be of the same sex. So in this case, we know it was 1/20th probability for them all to be women. So because there are the same number of men as there are women, the chances for getting all men is also 1/20th. Now you don't multiply the probabilities together in this case, because it's kind of an or thing. What's the probability of having all women or all men? Because of that, you add them. There's no cases where women are men or men are women, so you don't have to subtract anything. And so you just add this together and you get 2/20 or 1/10. Okay, so that was 46. This is 45. 47, it says no man will be interviewed until at least 2 women have been interviewed. Okay. So it's kind of like the beginning here, to have a man. So what we have is the first 2 steps is we have to have women. So we have the first 2 probabilities the same. Now at this point, so we had, what do we have? We had 3 women, 3 men, 6 people. The next step we had 2 women, 3 men, 5 people. So now at the last step is the one that's different. It says no man will be interviewed until at least 2 women have been interviewed. So in the third case, right now we have 1 woman, 3 men, for a total of 4 people. So the probability of picking a man in the last step is 3/4, because there are 3 men out of 4 people. So we should be able to do some simplification. This 3 times 2 is 6, and the reason I'm hesitating, I'm not getting their answer. Getting close, but not exactly. So let me just stop here and give me a thought to that. See what I'm doing wrong. Okay. So that last question, we'll leave out the step. So what it's saying is that what's the probability of the first, at least 2, no man will be interviewed until at least 2 women are interviewed. So we really don't care what happens the last step, because if it is a man, then if it was, what's the probability of a man being interviewed if 2 women are interviewed first? Well, what they're saying is at least 2 women. So we could have another woman in this case, and it would be at least 2 women. It could be 3 women, and then you'd have to be a man. So you don't have to have that extra step in there. You basically have the first 2 parts of this fraction. And so the probability of having the first 2 women is the same as the probability of having at least a man not interviewed until at least 2 women have started. So you get 3/6 over 2 times 2/5, and you can see 3 times 2 is 6, so you're just left with 1, and so the probability is 1 out of 5. Okay, so that's how that one works. Yeah, the last one is 53 through 56. So we have, what do we have here? Some coin biased. Making everyday decisions like who will drive to lunch or who will pay for the coffee are made by a toss of a presumably fair coin, and using the criterion heads you win, tails I will. This criterion is not quite fair, however, if the coin is biased, perhaps due to slight irregular construction or wear. John von Neumann suggested a way to make perfectly fair decisions even with a possibly biased coin. If a coin is biased so that the probability of getting heads is 0.52 and the probability of getting tails is 0.48, is tossed twice. Find each probability. So this is kind of like the basketball thing. So the probability of 2 heads is you take the probability of getting a head the first time times the probability of getting a head the second time, which is the same value, and you get a number. So we'll just do all of them, then we'll write the answers down. So the next one was the probability of getting a head and then a tail. So the probability of getting a head the first time is 0.52. The probability of getting a tail second time is 0.48. The probability of getting a tails and then a head is going to be the same as the other one. It's just you change the order that you're multiplied in. Because this is kind of like with replacement. You really don't have to, the probabilities are going to be the same to start with. They're just multiple part So you just multiply it by the two low probabilities, which are the tails. And so let's go ahead and get the numbers here. 0.52 times 0.52 is 0.2704. 0.52 times 0.48. And that's what you'll get for both of these because they're just a different order of multiplication. And then the final is 0.48 times 0.48. And you get 0.2304. And if you add all of those up, and I'm going to actually plug it into my calculator just to show you that I'm not just assuming anything. You add them up and you get 1. And that's because the probability of all of these added up has to be, I mean, these are all the options, so the probability of all the options has to add up to 1. Okay, so that's how that one works. So the question 57 says, having completed the exercises, can you suggest what von Neumann's scheme may have been? And I think, yeah, I'm not sure what I think, so I'm not going to say anything.